All right, as we look at Unit 8, we're going to be talking about interior and exterior angles of polygons. So again, just like kind of double check that you know your polygons. Here we've got a triangle. 4 sides would be like a rectangle or a square. 5 is a pentagon. 1, 2, 3, 4, 5, 6 is a hexagon. And again, it's just good to know some of these more common ones. 8 is an octagon, 10 is a decagon, and 12 is a dodecagon. If you count this, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. After it gets above 12, we just call it a 13gon, or again, quote, an n-gon. So however many sides there are, that's what we call it. So we've got names that we use for the under, or 12 sides or under, and then once we get above 12, we just start calling it by the number. So we're used to, triangles have 180 degrees, squares have 360 degrees. Those are numbers that we may know. And we've done before, but you might not know how many interior degrees a pentagon or a hexagon has. And this can be useful in the use of triangulation, which is again kind of like fancy for like surveying, and you can use the interior angles to determine actual distances. And again, this is a mathematician, Carl Gauss, that kind of perfected that technique. And again, a lot of people use it in like surveying land. It really helps you measure large distances without actually measuring the large distances. So if we look here, we've got this important angles theorem. You will need to know this equation. So again, make sure you've got this written down. S equals n minus 2 multiplied by 180. And again, n is the number of sides. And then S will give us our interior angles of a decagon. So again, a decagon is 10-sided. So we're going to say the sum of the interior angles equals 10 minus 2 times 180. Which is 8 times 180, which means the sum of our interior angles is 1,440. And that's for a 10-sided decagon. Find the measure of angle S. So, again, what I'm going to figure out is how many sides do I have? 1, 2, 3, 4, 5. It's a sort of a pentagon. 5-sided. So now I'm going to take my interior angles theorem and say the sum is going to equal 5 minus 2 times 180, 3 times 180. I believe it's 540. Let me double check. 540, yep. So this whole thing is going to equal 540. I see that I have 93, 156, and 85. So I'm going to add those up. But I got to figure out what I'm going to do with T and S. So I'm going to call these X. And since they're the same, that would be like adding up 2 of them. So plus X, that's like saying 2X. And then I just found that the total is 540. So equals 540. So let's do some simplifying. I've got like terms here. So 93 plus 156 plus 85. Woo! 334 plus 2x equals 540. We can subtract these. 2x equals negative 206, and when we divide by 2, or not negative, it's just positive 206. And then that means x is going to be 103. So the measure of angle S equals 103 degrees. The sum of the angles in a polygon is 3,240 degrees. How many sides does it have? So I'm going to do this equation again, but instead of, I'm going to figure out what n is rather than what s is. So 3,240 equals n minus 2 times 180. So if I use the distributive property, 180n minus 360 equals 3240. I'm going to add 360. And so I'm going to get 3240 plus 360 gives me a nice even 3600, and that's 180n. So if I divide by 180, again, I can just see, hey, my zeros are going to cancel out. 360 divided by 18 is going to equal 20. So how many sides does it have? 20 sides. All right. So this is an example of what an exterior angle would be. So it's kind of like you extend the line forever. So this is the exterior angle. This is an exterior angle. This is an exterior angle. This is an exterior angle, and this is an exterior angle. So you can see how the angles can change depending on the size of the shape. So we've got this theorem that says the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So again, if I added up all these exterior angles, they're going to equal 360 degrees. So all of them. So this one equals 360, this one equals 360, this one equals 360, and this one equals 360. What is the value of x in the diagram below? So again, using my knowledge, I know, all right, all exterior angles add up to 360. So 89 plus 67 plus 2x plus x equals 360. 89 plus 67 is 156, and 2x plus 3, or x is 3x. Subtract 156 on both sides. 204, and dividing by 3, you get 68. So x is 68. And that's the question. If the question had asked me for this specific angle measure, again, I would have to do 68 times 2. If it asked me for this one, I would just say 68. Find the measure of each interior and exterior angle in a regular octagon. So regular means that all angles and sides are the same. So if they're all the same, let's see here. My exterior angles, I know that they add up to 3. Octagons have 8 sides. So if I say, all right, I have a total of 360 angles and I have 8 sides, how do I break that up evenly? And I'm going to get 45. So the measure of each exterior angle all right, so I'm going to say the measure of an exterior angle is 45. If I wanted to find the interior, I'm going to use my formula. S equals n minus 2 times 180. But again, I know the number of sides is 8. So S equals 8 minus 2 times 180, 6 times 180. S equals 1080. And because it's regular, because of this word regular, I know that all the angles are the same. So I'm going to take my total amount of angles and I'm going to divide it by the number of sides and get 135. So the measure of an interior angle (135 degrees). There you have it.